Hello and welcome to this FortiADC's video on the DNAT packet forwarding mode in Layer 4 deployment. FortiADC is Fortinet's application delivery controller solution that provides Layer 2, Layer 4, and Layer 7 load balancing, SSL offloading, application acceleration, web application security, global server load balancing, etc. In this session, we'll walk through DNAT packet forwarding mode in Layer 4 deployment, how FortiADC processes traffic in this mode, the benefits it offers, and how to configure it effectively. In Layer 4 deployments, FortiADC is configured with a VIP that clients target instead of communicating directly with real servers. It inspects packets at the IP and TCP/UDP header level, and depending on the forwarding mode, it can modify the destination and source IP addresses. This allows FortiADC to support flexible packet forwarding methods, including DNAT, full NAT, direct routing, NAT4.6, and tunneling, making it suitable for complex network topologies, NAT environments, and multi-subnet architectures where direct routing isn't feasible. In DNAT mode, when a client request passes through FortiADC, it replaces the packet's destination IP address with the IP of the selected backend server. The source IP remains unchanged, allowing the server to see the original client identity. FortiADC then forwards the modified packet to the chosen backend server. After the server processes the request, it sends out the response with the client IP as the destination. To ensure that FortiADC remains in the return path and can handle the response properly, the server's default gateway must be set to FortiADC. FortiADC rewrites the source IP to its own VIP when it receives the packet, ensuring the client sees the response coming from FortiADC, maintaining consistent session state and seamless application delivery. As discussed, using the DNAT packet forwarding mode offers several advantages. First, backend servers see the original client IP address, as no source NAT is applied. This is ideal for environments where maintaining accurate client identity is important for logging, auditing, or security policies. Second, clients interact only with the VIP configured on FortiADC, not the real IP addresses of the backend servers. This setup prevents the exposure of internal server IPs to the internet, effectively hiding the actual server infrastructure and reducing the attack surface. Third, DNAT mode doesn't require servers to be configured with the VIP. They operate with their own IPs, simplifying deployment and maintenance. In addition to DNAT mode, FortiADC supports full NAT, direct routing, NAT4.6, and tunneling modes to accommodate various network topology requirements. Watch the related videos for detailed explanations of each mode, and refer to the network architecture guide available on the FortiADC documentation page for further information. Thanks for watching.